Well, now we're going to start section 3, which is graphing linear equations. And especially section 3.1, we'll make sure that we can read bar and line graphs, and we'll look at what the rectangular coordinate system is and how to plot points on the system and how to plot various points so we create a scatter diagram. We'll also be able to determine if an ordered pair is a solution to an equation that has two variables, and then we'll be able to find the missing coordinate of an ordered pair. So before we get started, these are some things you're going to need for Chapter 3. You're going to need some of your own graph paper, a notebook with graph paper, or just any kind of graph paper. The guided notes will have an XY coordinate system for the examples that we go through together, but you're going to need some for the work you're going to do on your own. You're also going to need a ruler because we're drawing straight lines and you want to be precise, and so get used to using a ruler. All right, so let's look at, first of all, let's look at example 1, graph, and let's approximate the number of internet users in Africa and in North America. So if you turn in your book to example 1, here's our graph. Let me see if I can get that a little bit closer. Let's see if this is better. Okay, it's not autofocus, but I think you can read the numbers a little bit better. I'll walk you through it. So here's example 1, and the way we read it, this would be a bar chart. This has horizontal bars. Sometimes you'll have a vertical bar chart as well. But you're going to want to read the title. This title says Worldwide Internet Users by Region, and here are different regions. So here's Africa and here's North America. We have Latin America, Caribbean, Europe, Asia. And along the bottom, the title is Internet Users in Millions. So this 200 here, this is not 200 users, this is 200 million users. And so if we want to, our question was to find the number of internet users in Africa and North America. We're going to find Africa and see how far the bar goes, and then go down to the vertical axis here and go, oh, you know what, that's like almost exactly between 200 and 300 million. So we would say that in Africa, and these are just estimates, we'd say right between 200 and 400 million would be 300 million internet users. How about North America? As we look at our graph, we're going to find North America, which is right here. And you know what? It looks like it's just a shade more than in Africa. So if we think Africa is 300 million, maybe North America would be 310 million. So that's just getting us used to always look at the axis, the graph title, and what's going along this vertical axis and what's being represented along this horizontal axis. Example 2 says, use the example 2 graph, and we want to know what is the pulse rate 20 minutes after lighting a cigarette. So as we look at the number 2 graph, so this is smoking versus pulse rate, and along this vertical axis it says the pulse rate, and this is heartbeats per minute, and along this other axis here, this is the time in minutes. So the odd thing about this graph is that 0 is not right here at the corner. This is when you light your cigarette. So this would be 5 minutes before you light the cigarette. This is 5 minutes after you light the cigarette. What's your heart rate? Here's 25 minutes after you light the cigarette. What's your heart rate? And so what can we tell from this line graph? We can tell when there's a slight increase, when there's a dramatic increase, when there are decreases, maybe slight increases. So we can kind of tell those trends just by looking at the shape and behavior of the graph. But this particular question says, what is the pulse rate 20 minutes after lighting the cigarette? So we're going to look at our graph here. And along the bottom, we're going to find 20. And then go up 20 minutes after. That 20 is really close to 70, a little more than 70. Okay, so that's actually between 70 and 80. So what do we want to say, maybe 74 beats per minute? At 20 minutes, we have 74 beats per minute. Again, these are not really precise graphs. It's just getting our eyes used to looking from left to right and from top to bottom. Name a 5-minute interval where the pulse rate is increasing. All right, well, that means where the number is going up. So you know what? Between -5 and when you light the cigarette, your pulse rate goes up. Maybe your heartbeat increases because, you know, you're anticipating having a cigarette. So from -5 to 0, the pulse rate increases. I think the most dramatic or the most noticeable would be from when you light the cigarette to 5 minutes after. There's a very large increase in your heart rate. You go from basically 60 beats per minute up to 95 beats per minute in 5 minutes. And then this looks like it's decreasing, decreasing, decreasing. And if you look right here, looks like there's a slight increase as we go down between 25 and 30 minutes. There's a slight increase in the heart rate. And this last question is the pulse rate ever less than or below 60 beats per minute? So what we want to do is find 60. Here's 60 beats per minute. Is the heartbeat ever less than that? And yes, it is. There's this little time period right here, just before you have your cigarette, the 5 minutes before you have your cigarette. So between 5 minutes before you have your cigarette and when you light the cigarette, the heartbeat is less than 60. Other than that, for all the other time frame after the cigarette, your heartbeat is over 60 beats per minute. So why don't you take a moment and do practice 1, which was the internet user practice, and practice 2, which is the heartbeat practice. Practice 1, you can tell it's practice 1 and there's a little green box, and then practice 2 is on the bottom of this page. Bottom of page 173. Okay, let's talk about the coordinate system. We have actually already solved problems where we said where x is 3 and where y is -4. X has the value -3 and y has the value -4, and we've substituted those into equations already. The shorthand notation for x is 3, comma, y is -4 would be this. This is called an ordered pair. Ordered because the order is important. The first number is the value to substitute in for x. The second number is the number to substitute in for the value of y. So this is a shorthand way to say x is 3, y is negative 4. So this is a shorthand way to say x is negative 2, y is 5. We start reading ordered pairs like that. X, Y, X, Y. Remember, X always comes first. And if you want to remember, even in the alphabet, X comes before Y, if that helps you remember which one comes first. So this is called the Cartesian plane, or the rectangular coordinate system. And it's basically two lines, a horizontal line and a vertical line. This horizontal line represents the value for x, or sometimes that's called the x-axis. This vertical line represents the value for y, and that is often called the y-axis. So this is the xy plane, or the xy system. And this point right here is called origin. That's the point where x is 0 and y is 0. And this is like a number line. So that's 1, 2, 3, 4, and on. And then this would be x is negative 1, negative 2, negative 3, and on. So your x's, this would be x is 0, and here's your number line. Along the vertical axis, along the y's, this is y is 0, and here's y1, y is 2, y is 3, y is 4, and the y's are increasing. It's like a number line, only it's a vertical number line instead of a horizontal one. And this would be y at negative 1, y at negative 2, y at negative 3, and going down to negative infinity. So the x and y axis actually break this coordinate plane into 4 quadrants. And we always start here. This would be the first, the second, the third, and the fourth quadrant. And they're always represented with Roman numerals. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. So if we want to plot where x is 3 and y is negative 4, we're going to go along the x-axis and go over 3 in the positive direction. 1, 2, 3. And then y equals negative 4, we're going to go down 4. 1, 2, 3, 4. That point right there is the point x is 3, y is negative 4. So here are your positive x's, here are your negative x's. Here are your positive y's, here are your negative y's. Let's say we wanted to graph the point negative 2, 5. X is negative 2, 1, 2. And y is positive 5, up 5, 1, 2, 3, 4, 5. Right there, that point is negative 2. That point represents the ordered pair negative 2, 5, where x is 2 and y is 5. So let's try practice 3, and let's plot these points. This will be our scatter plot, our scatter diagram. This is shorthand notation for x is 1, y is 3. Over 1 on the x, and up 3 on the y. And you don't need to make these points really huge, okay? Points don't need to be like, you don't need to make points like that big, okay? They don't need to take up a whole box. All right, how about the point x is negative 3, y is negative 4. We would read this, the point negative 3, negative 4. 1, 2, 3 in the negative direction, 1, 2, 3, 4 in the negative direction. That's the point, negative 3, negative 4. And then the point 0, 4, that means x is 0. X is not going to the left or right. It's staying at 0. And y is up 4. So we're not moving to the left or the right, but we are going up 4. 1, 2, 3, 4. That point right there is the point 0, 4. So what you're going to do is go ahead to practice 3, and practice 3 has you plotting, this could take you a little while, but practice 3 has you plotting these 8 points on your own piece of graphing paper.